Fantastic. All right. Good morning. Hello. Oh, fantastic. Hi, my name's Dave Iles. I'm with Mellanox Technologies, and I'm responsible for our Ethernet switch business. And today, I'm going to talk to you about doing cloud right and what that means. So first off, let's look at the cloud giants, the titans. So these are the great big innovators out of the US, and they have done good. So meaning they have come up with ideas and contributed them. Many of these are pretty well known. So for example, Google, their whole network, all software-defined networking. Facebook has been very public about publishing their Facebook fabric topologies. Hopefully you network guys are familiar with that and you've seen it and you've been impressed. You look at Microsoft. Microsoft has contributed an entire operating system called Sonic. So if you look at Azure, if you ever use Bing, the operating system that they use is something called Sonic, and they have open sourced it and contributed it to the community. You get to use that. Additionally, Microsoft has published a lot of papers around telemetry, and so you can freely look at how they measure things in their data centers, and you can learn from that. So if you look at some of these different things that these cloud giants have done, as I mentioned, Google, Facebook, Microsoft, they all have some things in common. The things in common are they almost all push layer 3 to the edge. So let me take one step back and explain who Mellanox is if you're not familiar with us. So Mellanox has been around for 20 plus years, and we are specialists in data center, meaning we make interconnect solutions for connecting servers to servers and servers to storage. We don't do campus, we don't do Wi-Fi, we do high-speed networking, which means that most of the supercomputers in the world that tell you if it's going to rain today or not, it's running our technology. If you look at most of the banks of the world, most of the automotive companies of the world, most of the oil and gas companies in the world, and most important for this conversation, most of the hyperscalers use our technology in their data centers. So that's why when I go to this slide and I say, hey, Google does this, Facebook does that, you can kind of learn that. And so what I'm going to talk about today is how you guys can learn from these, how you can stand on the shoulders of these giants and apply that technology into your own data centers. So first major web scale innovation that you'll see all of these guys do is something called network disaggregation. Some people call it white box. Hopefully, raise your hands. Have you heard of white box? Network disaggregation? So, the way it works is, if you were to go back, say, 25 years, 30 years ago, when you bought a server, you might go to IBM and you would buy the server from IBM. You get the hardware. Well, IBM would also sell you the operating system that went on that server. They'd also sell you all of the applications that went on that server. They even would sell you cables and optics, even though they don't make cables or optics. And nowadays, none of you would buy your servers that way, right? None of you would. You would buy your server hardware from one vendor, the operating system from another vendor, and all the applications would be someplace else. So an example of that would be OpenStack. But for some reason, a lot of people keep buying their networking today like they bought their servers 30 years ago, where it's all locked in. And anytime you're locked in and you're forced to buy from one vendor, you're going to pay more than you should because there's no competition. So we'll go to the middle here, this idea of open networking, where everything's broken apart. So this gives you the freedom to buy best of breed hardware, best of breed software, and get the optics from wherever you want. And so if at Mellanox, we embrace this approach. We say, listen, pick the best operating system for your needs. And some of the examples would be, if you look over here, we make an operating system called Onyx. It's great. It's a modern Linux-based operating system, and if you want to run containers of your own applications on there, it works great. However, if you wanted to use that Microsoft operating system called Sonic, Mellanox fully supports that. If you want a turnkey solution that was kind of best of breed for cloud data centers, we support Cumulus Linux on our switches. And I'll talk about why you might want to do that. But basically, the idea is that we give you the freedom to choose which operating system. Now, I've been told that many of you are developers. You know how to make things. And so one of the things that's nice about this approach is you could run a native Linux operating system. You could run CentOS on these switches. You could run Ubuntu on these switches. So that way, you have the control just as if it was a server. And so you can put your own applications on here with the idea that some people are afraid of putting applications on their networking. Because what if that application hogs up all the CPU? What if it hogs all the memory and it causes my data center to crash? So at Mellanox, we give you fine-grained controls for running containers on your switches. You can say, hey, I only want this container to get this much CPU. I only want it to be able to get that much memory. And then you can monitor and take a look and see, well, how much memory, how much CPU are these containers using? So these are all kind of neat innovations that are pretty important for building scalable, cost-effective data centers. Another important innovation is around where the layer 3 demarcation point is in your data center. It used to be, most data centers looked like over on the left-hand side of the screen. One big layer 2 domain. And in fact, many of you may even have networks that look like this. But over time, we've seen this demarcation point move down. Why? Well, if you think about one big layer 2 domain, one big layer 2 domain means one big failure domain. Meaning, how big is the blast radius of one device in your network? Like if you have a bad NIC, a bad CPU, something starts jabbering. If you have one big layer 2 domain, that means that one NIC can take down your entire data center. So one of the reasons why people are pushing things down as far as layer 3 is it makes that fault domain smaller and smaller and smaller. So that some people, it's very common nowadays to say, my top of rack switch is where layer 3 ends and layer 2 is in the rack. But we see even the more advanced guys even saying, you know what? I don't want spanning tree anywhere. I don't want MLAG. I don't want BPU guard and root guard and all the band-aids for spanning tree. So they'll run BGP right on their server. And then the benefit is I don't need ISLs for MLAG. I don't need a bunch of those things. And so you do see some people doing this. We have some very famous examples, folks doing that. Not for everyone, but it is kind of a trend going in the future. The nice thing about this too is you make for a very stable network. Now, the problem is that a lot of the server guys, they don't want to know about networking, right? They want to know about VLANs. They want to be able to, if I put an application on one of my servers, I don't want to know about IP routing and default gateways. I want to be able to shout, not route, to my other servers in that area. And so that's why the VXLAN has become very popular, because I can stretch a VLAN from one part of my data center to the other. And if you're using OpenStack, VXLAN becomes very interesting, because you could do it on the server, or you could do it on the switch. The benefit of doing it on the switch is your server doesn't have to understand VXLAN. It talks in VLANs. And OpenStack's pretty good at provisioning VLANs. And then you can let EVPN, let me go back one, kind of take care of moving and provisioning things around your data center. So this is kind of that demarcation point where if you're a certain size, it makes sense to do VXLAN on the top of rack switches. But for the ultimate scale, people tend to put it on their servers. The point to remember for you guys is that the cloud giants, they don't allow a lot of compromises when it comes to VXLAN. Meaning, if they're doing VXLAN, they also want to be able to do Rocky. They also want to be able to do routing and VXLAN at the same time. So we've come up with our hardware that doesn't give you any of those compromises where we say, you can only do this, but not that. Or you can do one at a time. With us, we can say, listen, you want to do Rocky and VXLAN and routing all at the same time? Go for it. We'll do it. Okay, another big innovation is around leaf-spine. So leaf-spine networks can be used with big modular chassis, but mostly they're not. So this approach of big modular chassis, this is a pretty common yesteryear approach, meaning 20 years ago, 90% of the data center ports looked like this. But nowadays, we're seeing more and more data centers looking like that. The reason is the price per port of the switches are like half of those modular chassis, 50%. But you get more redundancy, more performance out of the switch on the right. We talked about blast radius. Remember we talked a little bit about that? If I lose one of these switches over here, I've lost half the capacity of my data center. Over there, I've lost a quarter. I'm not worried, because I still have 3 other switches running. In this one, if I lose one of those switches, I'm really worried. My blood pressure's going up. Why? Because I have no redundancy left. If something bad happens to that one remaining switch, my name is maybe on the front page of the Wall Street Journal, right? It's a big problem. Where if it's leaf spine, no drama when you lose one switch. But the real thing here is not just me saying this. Let's look and see where are all the ports being shipped in data centers today. How much of the ports out there are fixed and how many are modular? And if I extended this chart, if I extended it back another 10 years, you would have seen this green line being at the very top, meaning not long ago, most of the data center ports were big modular chassis. Nowadays, 78%, almost 80% of all data center ports are from fixed port switches because it's more cost effective. Now again, some people, they'll go, hey, you really should stick with the old tried and true way of doing things. The guy telling you that is probably incented to do so because most of the network vendors, their sales guys make more money per dollar that they sell you selling these things versus selling those things, even when they offer both solutions. And so one of the reasons why you see this prevalence and why this chart looks like this is because you can build massive scale. And I don't know how many people in this room are going to build, 1,000 node networks, 10,000 node networks, but you can easily build in 3 tiers with very small switches, 100,000 node network. And that's why it becomes very appealing. You don't need those big modular chassis anymore. But if you can imagine what it looks like to configure something like this on the right, you think it might be pretty complicated, right? You're doing BGP, you're doing layer 3, you're doing EVPN. And so another innovation around webscale is to simplify things. Whenever possible, you want the configuration to be simpler. And so we partner with guys like Cumulus Linux. So Cumulus Networks has an operating system called Cumulus Linux. And to do a configuration, full, soup to nuts, layer 3, with layer 2, with MLAG down to the servers, with VXLAN, with EVPN, everything that you would possibly want, they'll do it with 11 lines of configuration. Versus the competition, if you look at what most switches take to configure those sorts of things, 92 lines of configuration. Let me ask you, which one would you rather do? Yeah, left, that's right. And so how do they work this miracle, right? Because it's not that you can't configure all of the things on the right on the switches on the left. What they have is they have experience, and they say, listen, 99% of my customers do it the exact same way because they're following the recommendations, best practices. So if you're following best practices, you're using BGP, you're simplifying your network, they know what all the default values, they set the default values to be so you don't have to configure them. Now, if you want to go in there and change things because you know better than the Cumulus guys, they give you access to all of that. But then your config's going to get a little bigger. Now, what about other innovations? So I don't know if any of you have heard of something called RoCE, or RDMA. But many of you have probably heard about machine learning, artificial intelligence, NVMe fabrics. So for those kinds of innovations, if you guys are looking at machine learning in your data centers, you may not realize it, but you're looking at something called RoCE. You're looking at a way to do lossless kind of networking on Ethernet. And so again, if you were to look at how would I configure RoCE on a switch? On a Mellanox switch, it's 4 letters. You type RoCE, you press enter, and then you go get yourself a cup of coffee. On a competitor switch, you're going to spend a little time configuring those things. And so again, this is a web scale innovation that the big guys do to make their life easier. And when I mean life easier, I mean easier to automate. So one of the things that you'll hear famously Amazon has said, they said if you have to do something more than once, automate it. Because chances are, if you think you have to do something twice, you're probably going to need to do it 20 times. And so that's how they can have an admin, like Facebook 5 years ago said, one of their admins, their network admins, can manage 5,000 switches. I was talking to Baidu last year. They said they can do way better than that. How? Because their network admins never have to configure, in fact, they better not configure a single switch. That doesn't scale. Instead, if they have to configure something, they use scripts to do it. They use automation tools. And that's how you get provisioning in minutes instead of weeks. It's how one admin can manage maybe thousands of switches. It also is how you drive down your operational expense. You do more with less. But it also helps you with other things. So when you read about in one of the papers that some data center went down, do you know why it usually goes down? It's usually one of two things. It's usually somebody misconfigured something, right? Someone fat-fingered something. They meant to say, interface 3 shut down. Instead, they said interface 5. Now the data center's down. So manual mistakes are pretty big. And if you automate, well, then you don't have those problems. But the other big problem is security issues. So most of you will have policies in your data centers, simple policies around security that would say, don't ever put a local password on a switch. Or you may say, don't put it in clear text. You may have other rules about how secure SSH and the key lengths need to be so that you're free from some hacker breaking into your boxes. These are common policies. And the problem is that if you're having humans configure your switches, sometimes they make mistakes, either because they're in a hurry, or they accidentally misconfigured it, or they're the new guy and they haven't been trained yet. But if you are using automation tools and you look at your policy based on the automation tool, your policies get followed 100% of the time, not 95% of the time. Because 95% of the time might as well be 0% of the time. Because as soon as you open yourself to a security issue, someone's going to find out. And so automation makes your network more secure, more reliable. All right. Another important innovation that we see across most data centers is a migration from the network services there used to be a tier in the data center that was called a services tier. And that's where you might have a huge firewall, some of them as big as me. And that's where you would put load balancers, you put a lot of things. And that made sense back in the day when all your traffic was north-south, when you had a big layer 2 network. The problem is that most data centers now have the majority of their traffic is east-west between servers. And if I have placed my firewall or my load balancer or my VPN at the very top of my data center, I end up with a problem called tromboning traffic, meaning I may have two servers, and those servers are standing or in the same rack. And I want to talk. One server wants to talk to the other server, but they're in the different VLAN, different security policy. That traffic needs to trombone up through multiple hops through the network, through the firewall, then back down. And so one of the trends you see is people pushing this services layer down. They put it down further and further and further. In fact, what we're seeing some people do is say, listen, all that complicated stuff that I used to have special hardware for, I'm going to use my servers to do it. I'm going to use software-defined networking. I'm going to use software-defined everything. So software-defined everything sounds like a great thing, right? I can change anything. But everything comes at a cost. So it used to be, you have a server. What did it do? It served. It did application processing. Meaning if you bought that server to do web serving and FTP serving and TFTP, and you had lots of applications you would run on that server. But now, the smart guys have said, hey, we're going to put software-defined everything, which means now I'm going to put vSwitches on that server. I'm going to put load balancers on that server. I'm going to have firewalls on that server. And every time I say I'm going to put another thing on that server, what I'm really saying is I'm going to take away one of those cores that you used to sell to your customers. I'm going to use it for infrastructure. And so every time I start putting a vSwitch, I put a firewall, I steal cores away. And that's the bad part about software-defined everything. It creates bottlenecks. And what you need is an intelligent NIC that can suck all of that processing out of those cores and say, we're going to do it in specialized networking hardware. not at the top of your data center, but right inside your server. And so this is a web scale innovation. You'd find most of the web giants that I talked about a second ago, they are all using SmartNICs. So how does it work? If you guys are OpenStack, if you're looking at OpenStack, we're talking about OVS probably. If you're looking at VMware, then you're talking about their own hypervisor, their own vSwitch. But if you look at OVS, for example, a lot of people love OVS. They're in love with it. There's a love-hate relationship here. The love part of it is I get to do a ton of things that I used to need dedicated hardware for. I can do switching. I can do security with VLANs. I can do quality of service, all inside my server. I can even monitor what's going on inside. I can have good telemetry. And I can all do it with a software-defined everything. So people love OVS, but it's a love-hate relationship because all of these things come at a cost. When I start doing vSwitching on a server, I see the CPU start ticking up. High CPU utilization from doing all these network services. The amount of throughput I get out of a server, doing it in software, is about a third of what I can get out of a NIC doing it in hardware. And then if I care about latency, and again, this is mostly for folks doing machine learning or artificial intelligence or high-speed storage, then you start caring about latency. So at Mellanox, we came up with a way to do kind of the best of both worlds. We're going to give you all the software control and all the goodness, the love stuff that you have about OVS, but we're going to accelerate in hardware. And we call that acceleration accelerated switching and packet processing, but ASAP squared for short. It's ASAP. Mellanox ASAP squared. And the way it works, so some of you guys are, so how does it work? So if you look at how software works, the first packet goes through what's called the kind of the user space of Linux, and you get all the control there. And then after that, everything kind of gets accelerated in kernel. Well, it works very similarly when you're doing this hardware accelerated approach, where you have an E-switch, an embedded switch inside of your NIC. So if you have a smart NIC from Mellanox, it has this hardware so that all the controls, all the stuff that you liked about OVS still work that way. The first packet goes through, it looks at it, but once you know that flow can be accelerated, you tell the hardware, OVS tells the hardware, accelerate this flow. So that way I can have lower CPU utilization, higher throughput, lower latency. How much higher? How much lower? So if you were to look at OVS, there's kind of three modes. There's the vanilla, I just run software. Unaccelerated, I can double the performance of OVS by using one acceleration technique called DPDK. And so DPDK is a way of accelerating lots of things. But it's originally designed by Intel for Intel, because the idea is that it's going to burn up more CPU cores. And so you can get better performance than vanilla if you use DPDK. And Mellanox makes the best DPDK switches or NICs in the business. But if you want to take the performance further, you want 10-fold improvement over DPDK, use this OVS offload. And so in this case, you can see that DPDK, which again works twice as good as vanilla, versus OVS, we will have significantly more throughput, and even when it's running at high speed, 66 million packets per second, the CPU on that server can be sitting idling, doing nothing. Or it could be doing what you want it to do, which is some services that you're selling your customers. So that's kind of the innovations around NICs. The other big thing that you'll see all of these big guys doing is move away from fiber channel. If you're still buying fiber channel, you might want to check yourself, because it's not the future. And you can see this year after year. For the last 10 years, fiber channel has been declining. And Ethernet has been the benefactor of that. Why? So again, if you look 20 years ago, fiber channel made a lot of sense. All right, you had to pay more for it, but there was lots of vendors selling it, and it was faster than Ethernet back then. It was lossless, and back then you didn't have such things like hyperconverged and software-defined, and there was no cloud 20 years ago. Fast forward to today, Ethernet is faster, 10 times faster than fiber channel. It's lossless. It has all of the support from the cloud guys. Meanwhile, fiber channel is now down to basically 2 vendors. It's a duopoly, they call it. And so Fiber Channel is on its way out, Ethernet's on the way in for storage. Why? So storage, if you haven't been watching closely, has increased in performance 1,000 times in the last handful of years. And that's not exaggeration. If you look at the latency from spinning media, from hard disks, versus the new high-speed flash from Intel and from Micron, they're down to now 8 microseconds seek time. Amazing. And what the cloud giants have figured out is that if they spend all of this money on expensive low-latency flash, and then they go plug this into their old Catalyst 6500 that's been sitting in the corner, they're not going to get their money's worth out of flash. What they figured out is they need, if they're buying low-latency flash, they need low-latency network to go with it, or they might as well be throwing away some of their investment. The other thing that they do is they accelerate that same storage using a technology called RDMA. I talked about Rocky a second ago. RDMA and Rocky go hand in hand. And so if you want to accelerate vMotion on VMware, if you're doing VMware, you can either do it without RDMA, which meaning when I move a virtual machine from one server to another server, CPUs peg, and there's only a certain amount of bandwidth that they can drive. You enable, you put the little check mark that says, no, I have a Mellanox NIC here, and then they turn on the RDMA feature. Suddenly they can do that vMotion instantly, and the CPU utilization on both servers can stay at 0 while that vMotion happens. And the magic is in this technology called RDMA. So one innovation that you'll find at these big mega scale guys is form factors that fit their needs. Meaning you won't find many 48 port switches in Google or Microsoft's or anybody, all these big guys' data centers. Why? Because they frequently will have 80 plus servers in a rack, and they don't want to use, they use these breakout cables, they use splitter cables, and so everything's QSFP. Now, the thing is that you guys may have your own needs. It's very common that you guys aren't putting 90 servers in a rack. In fact, for storage, many times you've got these 2U servers that have JBODs, and so you may be doing 12 servers in a rack, 15 servers in a rack. But that doesn't mean that you were going to go back to buying the old 48 port switches. So at Mellanox, we make switches ideal form factors for that use case. Meaning, if you only need 15 ports, why are you buying a 48 port switch? And so we have these little half-width switches, which it's not obvious, but they go in regular server racks, side by side. 2 of them provide redundancy. But because they're half size, they have half the sheet metal. Right? They have half the cages, half the fans, their motherboards are half size. So they end up being about half the cost of those big full-width switches. The only thing that's not half size on those switches is the core. The heart of the switch is called the switch ASIC. We use the same switch ASIC on these little switches as we use on our big switches. So you don't give up any performance by going to these little tiny switches. So this is one of those web scale innovations that is coming to the smaller data center. The guys that may have a co-location and they're not even filling up a whole rack. They're doing a half of a rack. And so one of these switches that only has 57 watts of power is perfect for that, because that leaves more power for your servers. It leaves more space for your servers. And it's optimized for Rocky and for all of these things we talked about before. Last innovation. So this is maybe the most important thing. You know, you want to end on a high note. So one of the things you'll find, you might think that the smarter the network guy is, the more advanced he is, the more features he has running in his data center, the more protocols he's going to run in his data center. And I'll tell you what, the opposite is true. When you go to the most advanced data centers of the world, they don't look like the right side of this picture. They look like the left side. They look like the right side of this picture. They try to get down to 2 or 3 protocols running in their data center. Why? Well, if I have fewer protocols running, there are fewer things that can go wrong. There's also fewer attack surfaces for security issues. When I need to troubleshoot, there's one protocol I need to go look at. I don't have to kind of figure out, is this a layer 2 problem or a layer 3 problem? Is it a layer 4 problem? I got one protocol running. And so this is a common trend. The exception to this trend towards simplification is around telemetry, visibility. So as mentioned, there's this idea that you want to automate everything. but you also want to measure everything. Why? And so why do you want good telemetry? So the first thing, if you kind of look over there, there's this idea of figuring out how things went wrong. So if you're a network guy, you're pretty familiar with this idea that when something goes wrong in the data center, the network gets blamed. And so the network guys have come up with this idea of mean time to innocence. How quickly can I prove it's not my fault and it's somebody else's fault? And the only way you get to lower that mean time to innocence is with good telemetry. And if it is your fault and you want to fix it, again, you want good telemetry. And if you're a CIO out there and you're thinking, well, why do I care about telemetry? Telemetry, or metrics, are how you tell, am I getting the most out of my network? Am I getting the most actually out of my data center? Because I'll tell you what, people worry that they might overspend on their network. And I'll tell you when it's way, way worse than overspending on your network, underspending on your network. Because you know what, if you have bottlenecks in your network, that means you're not getting your money's worth out of your servers and your storage. And I'll tell you what, you're spending a lot more on servers and storage than you are on networking. So, we have come up with this technology called What Just Happened. And this turns network monitoring on its head. So the way network monitoring works pretty much everywhere in the world is you collect innocent data, innocent stats. I collect counters on ports. I collect stats on packet drops and the like. And I'll even do things like S-Flow, which works like security at the airport, where it'll randomly sample things and say, oh, I'm going to pull you out and I'm going to inspect you a little more closely. But the way all of these things work is when something goes wrong, you, the network guy, have to spend your weekend sifting through all this data to try to figure out and guess, extrapolate what went wrong. And so we created this technology called What Just Happened with a singular goal. We want to give you your weekend back. So what we'll do is we go ahead and we say, listen, we're going to hand you, when something goes wrong, we're going to hand you the smoking gun. We're going to hand you exactly what went wrong in your data center, so you don't have to guess. So let me double click on that a little bit and say, so how does it work? How are you going to do that? So pretty much every data center in the world, every switch in the world drops a packet from time to time. Sometimes for good reason. Like if you hit a security ACL, you want to drop that packet. Sometimes for bad reasons. Now see, the thing is that pretty much every switch on the planet, when it does drop a packet today, that packet, it goes to bit heaven, never to be seen again. And so the most that switch will do is increment a counter. And that counter will say, you've now dropped 5,040 packets because of bad VLAN. And you go, that's great. But you don't know, is the switch misconfigured? Does it not have the right VLANs configured? Is the server misconfigured? Is it the storage? You don't know. Well, with What Just Happened, we kind of remove that mystery, because on a Mellanox switch, when we drop a packet, we hold on to the information you need, and we tack on a bunch of metadata, timestamp, switch ID, port ID, and most importantly, why things were dropped. So that way, when something goes wrong, someone says, hey, I had a problem yesterday, and it was with the web servers over here. Well, you can start looking at TCP dumps and things like that, but by then the problem has probably moved on. It's disappeared. It's very hard to recreate. But if you have a Mellanox switch, you check the logs, and they'll say, you have a problem here. It's impacting those guys, so it'll tell you who's impacted, when it was happening, where it was happening, and most importantly, like. The whole goal is to kind of get you root cause quickly, because if we can save you time, we're saving you money. And so we look at not just regular drops like layer 1 packets, layer 2 packets, layer 3 information. There's a very common problem in data centers where you do low latency called cut-through switching, and a bad packet might move from one switch to the next switch to the next switch, and it's very hard to see, well, that's the other webscale innovation that you might be surprised to hear. The really big guys, they don't care if a port goes down. What really drives them crazy is when a port stays up, but it kind of fails. When a port kind of fails, that is the worst in the world, because the link is up, but it's still causing problems.
Okay, thank you very much, Mr. David. Question and answer.
Or something else, you can ask to Mr. David. Sesuatu kepada Bapak David.
Oke, kita ada kita buka 3 penanya. Oke, baik. Mohon untuk mic personnya.
Okay, thank you for your time. So I want to ask about how Mellanox work with another switch. Is that feature that you're talking about there is still running or not?
Great question. So the question is, when you look at what just happened, and you said it, so you have all this great stuff, but do I need to have your switches everywhere in the data center to take advantage of it? And the answer is no. So meaning, imagine I have a leaf spine network, and so we went back to this picture of a leaf spine network, and I have one of those switches is a Mellanox switch, and the other 3 switches is somebody else's switch. And so with the Mellanox switch, you have this what just happened feature. Well, you can say, listen, I may not get all the alerts on the other spine switches, but if you have the Mellanox switch as one of the spines, you will start seeing these alerts. And then you'll be able to know, if I see these kinds of drops on one of those spines, chances are I'm seeing on the other spines. In fact, there's a high correlation. And the same thing's true for even the leaves. If I have a few of the leaves that have this feature, I may not need it on every one of them. So it's not meant to be something where I have to rip and replace your entire data center. Because I'll tell you what, nobody wants to do that. Going on. They had no idea that those were going on in their data center. But it's an excellent, excellent question. Thank you very much.
Kita ada pertanyaan lagi, mungkin ada yang bertanya. Ya, diulangi.
Thank you. I have a question. We are using Nutanix hyperconverged in our data center. Is it possible that Mellanox switch controlled by Nutanix Prism? Thank you.
So is this, you asked if we work with Nutanix Prism? If I understood the question, if we worked with the Nutanix Prism with our switches?
Yes.
Yes. So, for those that maybe are not as knowledgeable as the questioner, Nutanix is a very popular hyperconverged solution. In hyperconverged, a lot of people go, what the heck is that? It's a cloud in a box. So if you want public cloud experience, but you want it in your basement, if you want it in your own data center, and you want the automation to work just like AWS or Azure, but you want to own the infrastructure, that's where Nutanix comes along. They're very good at it. And so then they have this whole idea around making the infrastructure invisible, right? Just like you don't need to know much about your AWS infrastructure. All you know is, I bought 50 virtual machines and they're running just fine. Well, they want the same kind of experience out of their hardware. So they will sell you a box, and it can be supplied by a number of different server vendors. But their big value to you is that you don't need to know all the little things about the hardware. They make the infrastructure as invisible as a public cloud, but it's in your basement. Now with Mellanox, we try to do the same thing, especially with Nutanix. What we do is we try to make the switches invisible as well. And the way we do that is we have integration with Prism. If you have one cluster, it works great. Meaning I have a virtual machine and it gets deployed, and you don't need to know much about the hardware that it gets deployed on, but we do. The switch needs to know. And so Prism talks to our switch, and it will provision the VLANs, the security policies, and stuff like that. And then you do a live VM migration, you say, hey, actually I want to move that virtual machine from this server to another server. It works perfectly. But imagine you have two data centers, or you have a disaster recovery site. So let's say you do have it in your basement, and then you have a co-location site for backup. And you want the same feeling. You want to be able to say, listen, if I move that virtual machine over to the public cloud or to my co-location facility, I don't want to have to know everything about it. And so we also work with what's called Prism Central. And so Prism Central is for those multi-site configurations for Nutanix. And so Mellanox. Neo is if boy.
Okay, we still open. One question again.
Last questions.
The last question. Could
Pakai
you
bahasa
please?
Indonesia juga nggak apa-apa.
Yeah. Okay.
Yeah.
The last question. Great.
One last question.
Thank you for the time. I want to ask about did Mellanox has their own routing protocol like we know Cisco has IGRP or EGRP?
Okay, so the question is, does Mellanox have our own routing protocol like Cisco has EIGRP? And in general, so the short answer is no. In fact, it's easier for us sometimes to innovate if we just created our own proprietary version of something. We are really committed to the open community, and so we don't do proprietary almost anything. In fact, lots of things we contribute. Like I talked about Microsoft Sonic, we're the #2 contributor to Sonic. If you look at just not of networking, just in general for Linux. So we're huge on open source. So even though it might be easier for us to create, it's going to interoperate with everybody. Another excellent question. They're all 5 out of 5 on difficulty score.
Okay, thank you. Thank you very much. Okay, so Mr. David, could you please help us? There is 3, we are so confused. Which one the best question? Question number 1, question number 2, or question number 3?
Okay, I think we ought to go by crowd applause. Who
Okay.
liked question number 1?
Number 3.
I think it's pretty clear.
Okay, question number 1. Congratulations. Okay, thank you very much,
Thank you.
Mr. David, for the insightful talk.